As we go forward learning about functions, I think it will help us to introduce the idea of initial value when dealing with situations that can be modeled by functions or by arithmetic sequences, which of course, as we just went over, are themselves functions, right? So let's take a look at this scenario. Paul is saving to buy a new car. He started with $800 in his bank account. He is going to save $100 each week from his paycheck. Okay, so let's introduce the idea of initial value. Before he even started saving, right? Before he started the process, which this sequence is associated with, he had $800 in his bank account, right? So let's call that term y sub 0. Y sub 0 equals 800 because that's the amount he always had. That's the amount he started with before this process that the sequence or the function is representing even started, okay? So therefore y1 would be, after he saved from his first paycheck $100, the value of y1 would be 900, the value of y2 would be 1000, right? Value of y3 would be 1100, value of y4 would be 1200, right? And as always, we can write this as, remember, a recursive sequence. Y sub n, current term, equals y sub n minus 1. The previous term plus the common difference, which in this case is what? The common difference is 100, right? So, of course, we could just keep going if we wanted to find y5, right? We'd need to find y4 plus 1200, right? Whoops, my bad. We would need to find, let me erase that. We'd need to find y4 plus 100, right? Which is 1200 plus 100, which is 1300 or 1300, right? Similarly, what's y6? y6 is just y4. Sorry, y6 is just y5 plus 100, get you 1400. We could keep going on and on, right? Y7 is just y6, the previous term, plus the common difference, which in this case would be 1500, right? So we know how to do that. We can do that all day long. We can get any value of the sequence that we want, okay? But now that we've introduced this idea of initial value, let's look at another way we could write this. We could write yn, right? So what is yn? Well, what's the process? Well, we started with our initial value, right? And what did we do to get yn? We added by the common difference that many times, right? Let's go through this explicitly first. So we started with yn, right? So how would we find y1, right? Whoops, let me my color back. y1 would be y0 plus 100, right? y1, sorry, y2, right, would be our initial value plus 100, right? We started with our initial value and we added the common difference twice. Or we could write that as y0, the initial value, plus 100 times 2, right? y3, that would be the initial value, right? How did we get to y3? We started with our initial value, 800, and we saved for 3 weeks. So we started with our initial value and saved $100 for 3 weeks. So we can call that plus the common difference times 3, right? Or if we wanted to find any value of n, right? Any value of n, we would take yn equals the initial value, y0, plus the common difference times n. And the two terms here really describe the same thing. They're just written in different ways, right? We have we can call this, well, we do call this our recursive function, right? Recursive function, right? And this is just a different way to write the same thing, right? So let me just show you. We can be sure that we're going to get the same results no matter which one of these we use, right? What if we wanted to calculate, let's say, y3, right? If we wanted to calculate y3 using the recursive formula, we would find the previous term, y2, and add our common difference, right? We'll look at our list. What is y2? It's 1,000, right? 1,000 plus, whoops, let me erase this. I'm sorry, guys. Let me get rid of this. Let's remember y2 was 1,000, right? y2 was 1,000 plus our common difference 100 does indeed equal 1,100, 1,100. We got that right. Or we could use this formula here. Yn equals the initial value plus 100n. If we wanted to calculate y3, right? Well, we would just take our initial value, 800, right? Plus 100 times n, in this case, times 3. This is going to be 800 times 100 times 3 is 300, right? And we'll again get equals 1,100 or 1,100, right? Same thing. Both sequences will get you the correct answer. It just may depend on one formula being more useful in one scenario, maybe another formula is more useful in a different scenario, but we definitely want to make sure we recognize both and know how to work with both. Okay, let's consider this scenario. A school has just opened up its enrollment. It had 230 students to start with. Now, 8 more are enrolling each day. The following table lists how many students the school has at the end of each day since they opened their enrollment. Okay, so days 1 through 7 on day 1, after 1 day of the open enrollment, there are 238 students. After 2 days of open enrollment, there are 246 students. After 3 days, there are 254 students, and so on, right? So let's write this in both of the formulas we're using right now, right? And let's even write it as a function, right? Let's write this as a recursive function. Let's write it as a recursive function, okay? Recursive function. So remember to find the value of f of n, which would be the nth or the number of students on the nth day, right? You take f of n minus 1 plus the common difference here, which would be 8, right? For example, if we wanted to find, let's say, f of 6, right? We'd need to find f of 5 plus 8, right? We can look at our table and see that f of 5 is equal to 270, right? And we can add the common difference 8, we'll get 278, right? Just like we have in reality, okay? That's the same way, right? We could write this as a recursive sequence, right? We can write this as a recursive sequence, which is yn equals yn minus 1 plus 8, right? You see, these are pretty much exactly the same, except we call the first one we wrote a recursive function just because it's actually written in function notation, right? So yn equals yn minus 1 plus 8, like if we wanted to find, y3, what would we have to do? We'd have to take y2, the previous term, add the common difference, right? What is y2? We know it's 246. 246 plus 8 is going to be 254, right? And we got exactly what we know the third term in the sequence to be, okay? Or we can write this non-recursively, right? We can write this in the form yn, right, equals the initial value plus the common difference 8 times n, right? So if we wanted to know what is the value of y sub 7, right, how many students are enrolled 7 days after the enrollment began, we would try to find our initial value, the value we started with, right, which in this case is 230 plus 8 times n is 7 in this case, right? That's 230 plus 8 times 7. What is 8 times 7? It's 56, right? It's 56. And what is 230 plus 56? It is 286, right? And is that what we know y7 to be? Yes, it is. Of course, we can also write it this way. We can also write this function or this sequence non-recursively, right, in function notation. How would we do that? Well, that's simple. F of n, right? F of n would equal your initial value. Since we're not using the subscript, since we're not using y, so we're not going to use the subscript y for initial value, we can just call it, f of 0, right? Or just 230 plus the common difference 8 times n, right? F of n equals f of 0, that's your initial value, right? Plus 8 times n. So we know f of 0 equals 230, right? F of 0 equals 230 since that's the initial value. And the real benefit of writing it like this or like this is that if you want to find the value of some term in the sequence, you don't need to know the value of the term immediately before it, right? Like if we wanted to know how many students there would be if this school ended its enrollment period after, let's say, 15 days, right? We can calculate f of 15, and we don't need to know what f of 14 is, right? We don't need to know what the value of the last term is. We can just plug it into this formula. Your initial value, 230, plus 8 times 15, right? And that's going to be 230 plus, what is 8 times 15? It's 120, right? And 120 or 230 plus 120 is going to be 350, right? So we can use this formula to tell us that if this school kept its enrollment open for 15 days, it would have 350 students. And we don't even need to know the value of the previous term or the previous value, which would be f of 14, to know the value of f of 15.